right, we have another minute or two. Is there anybody that hasn't got their tests back? Is Chloe here? How about River? Oh, not here. Let's see. Right. Okay, I believe we had said there would be another study group today at 1 o'clock. Didn't we have a study group last Thursday at 1 o'clock? So there'll be another one today at 1 o'clock if you are available and interested. It's going to be in the Mars lab, which is room A101, because that's where we had to meet last time. So if you would like, I think we'll be doing 3.2 and 3.3 in our review today. We did 3.1 last week. So there's a study session today at 1 o'clock. Now, I do not have a study session scheduled for tomorrow because we didn't have very good attendance last Friday. So we're not going to do one tomorrow. And everybody's aware that spring break is next week, right? So nobody will be here, so there's no sense in coming next week, okay? So keep that in mind also. Now, I would like to offer some extra credit. So here's what I'm going to tell you. Anybody who has finished homework 1, 2, and 3 of, aren't we in chapter 3? Wouldn't it be 3.1, 3.2, and 3.3? If you have finished 3.1, 3.2, and 3.3 in the Math Excel, by the time we get back from spring break, you will automatically get 3 points extra credit. Okay? So, some of you have already finished 3.1 and 3.2, right? So if you just do your 3.3 before the end of spring break, then you're going to automatically get 3 points extra credit. And then when we come back from spring break, on the day we get back from spring break, we're going to do some more extra credit during class. So that's just heads up, so you guys know in advance, okay? So just wanting to let everybody know we're going to be doing some extra credit. All right. In one of my other classes, someone had asked me, when will we know about the AMATIC test? Some of you took the AMATIC test. I don't know when we'll know. We don't grade the test. We have to send it to National, and they grade the test, and then they send us the results and all of this. So I've been told that we'll be told who came to the AMATIC test, but we won't be told what your score is for several weeks now. So it may be a week or two after spring break before I find out. But just know, if you took the AMATIC test, automatically, what do you get? 5 points, extra credit. And for every correct answer, once I figure out how many correct answers you had, then I'll let you know how many extra credit points you get. So unfortunately, I don't control the grading of that. And so we have to just wait until it comes back. All right, today we're going to do section 3.4. And most students tell me this is the most challenging section of the entire course. So I'm glad you did not skip class today. And I see a few extra empty seats, which means some people are really going to wish they had come instead of starting their spring break early. To do today's lesson, we have to learn another theorem. So I've written the theorem and put it up here on the screen. It's called the rational zeros theorem. Last class, we talked about factor theorem and the remainder theorem. Right? Mostly, it's the factor theorem that we need. So we have the remainder theorem and factor theorem, and now we have something called the rational zeros theorem. And when you're writing this down and you're reading it, it probably doesn't make a lot of sense. This is my version of the rational zeros theorem. The problem with the rational zeros theorem in the textbook is they use some symbols that aren't as clear to people. So I changed some letters in the actual theorem. So it's called the rational zeros theorem. And in order to explain the rational zeros theorem, the best thing for me to do is to do an example. So I'm going to give everybody another minute or so to finish writing down that rational zeros theorem. And then I'll do an example to help make it clear. Okay, let's kind of describe the rational zeros theorem before we do our example. Notice it says f of x is a polynomial, and we've been working with polynomials. We're going to do polynomials that are degree 2, degree 3, degree 4, degree 5, etc. So it has to be a polynomial, and do you notice it says with integer coefficients? What are integers? They are numbers. What kind of numbers? They can be positive, but they also can be negative. Will a fraction be an integer? Like 2/3, is that an integer? No. So don't they have to be whole numbers, right? Positive whole numbers and negative whole numbers. Those are called integers. Now, when it says integer coefficients, that means the number that's right before x to a power. For example, 7x to the third. Isn't 7 the number before x to the third? That's my integer coefficient. So when it says my function has to be a polynomial and it has to have integer coefficients, isn't that what we're used to? Most of the problems we do are not going to have fractions in them, and they're not going to have decimals and square roots in them. They're going to just be nice integers in the polynomial. Well, when we have a polynomial that has the integer coefficients, what we need to do to use this theorem is make a list of all the factors of the constant. Now, do you know what the word constant means? When you have a polynomial, which part of the polynomial is called the constant? Which number is it? The first number or the last number? The last number. When you have descending order, isn't the last number a number without an x? Right? The number that does not have an x is your constant. So if I saw a certain number, I would have to write down all the list of the factors of that number, which would be my constant. And then I make another list, and I call it Q, and that's a list of all the factors of the leading coefficient. What does leading coefficient mean? The first one, right? The very first number that's in front of x to the highest power of the polynomial. So I make a list of all the factors of that number. And if I take every number from the list that's P, and I divide it by every number from the list that's Q, that set of fractions will give me a list of all possible rational zeros. Now, you may wonder why in the world we need a list of possible rational zeros. Well, think back to last class. Didn't we have to find the zeros when we had things that we couldn't factor? And we had to use the factor theorem. Well, on every problem in homework 3, in 3.3, didn't you notice they always gave you a hint? They either said, divide by x plus 1, or they said, 7 is a root, or 7 is a 0. Didn't they give you a hint on every one of them? Well, now they're not going to give us any hints. They're just going to give us the problem and say, here, find all the zeros. There are no hints. The only way to start this problem is to do this to get a hint. We got to figure out where to start. And so that's where this theorem comes in. So hopefully you've had time to write it down. If not, see me after class and I can show you this piece of paper. But let's do an example of using that theorem. The rational zeros theorem gives you a place to start. Now in number 6 on page 386, which is in section 3.4. Problem number 6 has this polynomial that's degree 4. And the directions say, list the possible rational zeros. List the possible rational zeros. Now, if you look back at the rational zeros theorem, yes? Yes, that's the 3x squared. I'm sorry, I got curly. I apologize. Sometimes I just start curling things. But yeah, this is a 3 and that's a 3. So I just happened to curl one of them. So 3x to the 4th minus 11x to the 3rd minus 3x squared minus 6x plus 8. Sorry about that. Okay, so if I said list the possible rational zeros, notice it doesn't say find all the zeros. Now, if it said find all the zeros, this would be a very difficult problem. How do you find all the zeros? Well, first of all, if I said find all the zeros, how many would we be looking for? 4. How do you know it's 4? Because you're correct, it is 4. What tells me how many zeros I'm supposed to get? Right, the 4th power tells me I'm supposed to have 4 zeros. And can you factor that? Did you ever learn how to factor things that had 5 terms in intermediate algebra? No, we only factored the ones with 4 or less. So this one has 5 terms, and we're supposed to factor it. So we're going to have to use the factor theorem. But do you notice they didn't give us any clues? So if they asked me to find all the zeros, I have no clue where to start. So in this problem, they want to teach you how to know where to start. And so in the directions, it says list the possible rational zeros. You see the word possible? Possible zeros. Now, if I have this list, well, I know at least some of those numbers have to be zeros. Right? Possible means some of them are zeros and others are not. But at least does it give me a place to start? Right? So that's where this theorem comes from. So if I said let's list the possible rational zeros, we have to write down our P's and our Q's. Now, the only reason I'm using the letters P and Q is because 30 years ago when I was taught college algebra, my teacher used P's and Q's. And so I use P's and Q's. If you don't like the letter P and the letter Q, can you pick any letters of the alphabet you'd like? Just don't pick X. Yeah, so you can pick any letters you want. The textbook uses A sub 0 and A sub n. And I don't like that. The textbook will have an A sub 0 and an A sub n. Is that just like a P and a Q? Yeah, they're different because that has a 0 and that has an n. So if you want to use the symbolism that the book uses, that's okay as well. But I'm going to call them P's and Q's simply because P and Q is easy to remember. So when it says list the possible rational zeros, I always do my P's and Q's. Now, P's are all the factors of the constant. So if I say, what's the constant? Right there's the constant. So if I say, look at the constant, it's 8. What are the factors of 8? What can we multiply to get 8? 2 and 4, right? And 1 and 8. Are those the only factors of 8? Well, you've listed half of them. What's negative 2 times negative 4? 8. What's negative 1 times negative 8? 8. So really, do we have to list positives and negatives? Because can we multiply and get 8 both ways? Right? So since we're listing both, here's what I would do. Plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Most of the time, if you are looking at examples where they're listing all the factors, they list them in numerical order. It really doesn't matter whether you list them in numerical order or not, but I'm going to list them in numerical order just to be consistent. Okay? But if you wanted to say 1 and 8 and then 2 and 4, did you still list them all? Right, so the order really doesn't matter. So P is a list of all the factors of 8, the constant. Okay, are you with me on how to find P? Okay, so now let's find Q. Q deals with the leading coefficient. Three is the leading coefficient. So if I said, list all the factors of 3, what would you say? Right, plus or minus 1 and plus or minus 3. Is that all to get 3? Yeah, that's it. So I'm going to say plus or minus 1, and I'm going to say plus or minus 3. So to list the possible rational zeros, you make both of those lists. You write down your P's and your Q's. P represents the constant, Q represents the leading coefficient, and we put all the factors. The list of possible rational zeros, would be every P divided by every Q. Now, did you hear the word every? Every P divided by every Q. So what I try to do is come up with a pattern. I'm going to take every one of these P's, there's 8 numbers here, and I'm going to divide all of them by the first Q. And now I'll write down that list. And then I'm going to take every one of the P's and divide them by the second Q. Now, if there had been a third Q, would I have to take every one of the P's and divide by the third one, et cetera, until I got to the end? All right, so start at the beginning. We're taking all of these numbers up here, and we're dividing every one of them by 1. So what's going to happen when I take all 4 of these numbers and I divide them all by 1? I'm going to get all 4 of those numbers, right? And we're going to put plus or minus, so there's really 8 numbers. So we have plus or minus 1, and we have plus or minus 2, we have plus or minus 4, and we have plus or minus 8. So I took every one of them and divided by 1. Now I have to take every one of those numbers and divide it by 3, because the second number was 3. What do you get when you take 1 and divide it by 3? What fraction do you get when you take 1 and divide it by 3? 1/3. So we have plus or minus 1/3. And then I have to take 2 and divide it by 3. Wouldn't that be 2/3? Okay, what's the next fraction? What do you think? What's the next fraction? We have to divide every one of these by 3. What would we get for the third fraction? 4/3, right? Plus or minus 4/3. Okay, and how about the last one? What do we get here? 8/3, right? I don't think any of those reduce, do they? If you get a fraction that reduces, for example, what if that said 8/4? If we had 8/4, could you reduce it and put a 2? Yeah, if it reduces, reduce it. Also, if you get a number that's repeated, if I get a number that's already in the list, don't write it twice. The list is long enough without repetition. Right, so don't write it twice if you get a number that gets repeated. So the list of possible rational zeros would be the list that includes every P divided by every Q. Have I divided all the P's by all the Q's? Nope, this is the list. Now, I believe in the Math Excel program, there is no plus or minus symbol. Am I correct? On the keypad, I don't think they have a plus or minus symbol. So when you're asked to list all the possible rational zeros, well, you have to write 32 numbers. Well, actually, it won't be 32. Let's see. That's what? 2, 4, 6, 8, 16 numbers here. 16 numbers. Would you have to type in 16 numbers? Yeah, there are 16 numbers there. And I wish they had a plus or minus symbol. You could just click plus or minus and then put the number in. On paper, this is the best way to write it. But in the computer, I think they make you have to type 1, comma, -1, 2, comma, -2, etc. So I apologize that that is not available. So what's the purpose of that list? Well, it gives me a starting point. Now, here's the bad news. It's not very precise. Don't we have 16 numbers there? Well, if I were asked to find all the zeros, there are 4 of them. If I were just randomly asked, find all 4 of the zeros, and I didn't know how to factor it, I would have no clue. Aren't there millions and millions of numbers? So isn't 16 better than millions? Well, yeah, if you put it that way. But 16 is not so good, is it? Now, in this problem, they didn't say find all the zeros. We're finished with this problem because the directions just said list the possible zeros. And is this the list of possible ones? Yeah, these are the possible rational zeros. So I have my list, I'm done. But in the next problem we're going to do, they're going to say list all the possible zeros and then find all the zeros. So let me explain the thought process. After you make this list and you say, I've got 16 numbers here, then you use what you know. Now, last class, do you remember we typed a formula in the calculator and we looked at the picture and we found the zeros? Do you remember working backwards? And we did that in section 2 and we reviewed it last class. So, if I were to put this in my calculator and graph it, could I look at the picture and find some of the zeros? Well, when I look at the picture and I compare it to this list, should some of those zeros that are on that picture be in this list? That's how I know where to start. And you might say, well, I really don't need the list. I've got my calculator. Well, what if all of the zeros are ugly, like 2/3 and 4/3 and 8/3? When you look at the picture, are you going to say, oh, that's 8/3? Probably not. But if you have the picture and this list, would you be able to say, oh, it might be 8/3 right here? Because do you know 8/3, let's see, 3/3, 6/3, 8/3, it would be 2 and 2/3. Right? If it looked like it's close to 3, would you say, oh, I might need to try 8/3? Right? So the purpose of this list is to help you with the calculator because not all numbers are really nice, pretty numbers. Will some of them be very easy to see? Sure, and others won't be. So if you have the calculator and this list, can you know where to start? See, that's the purpose of this list. So let's do a problem where they make us do everything. And they just say, find all the zeros. And they want us to find all the zeros by using the factor theorem. So here's number 12, and that's on page 387. If you have your book and want to look in the book, page 387. And problem number 12 gives us this polynomial. And in the directions for number 12, it says, Part A, list the possible rational zeros. So let's start with A, possible rational zeros. So if I'm going to list the possible rational zeros, what are my p values? I look over here at 2, what are my p's? 1, right, plus or minus 1, plus or minus 2. And we get that from the constant. Okay, how about q's? Somebody else, what would be the q's? Look at your leading coefficient. Oh, we're lucky, that's the same number. What do we put for q? Right, plus or minus 1 and plus or minus 2. Very good. So, could everybody write down all the p's and all the q's? Now take every p and divide it by every q. So start by dividing all the p's by 1. So p over q would be plus or minus 1 and plus or minus 2. And then what do you get when you take 1 and divide it by 2? Right, plus or minus 1/2. And what about 2 divided by 2? Ooh, that one reduces. What's 2 divided by 2? 1. Is 1 already in the list? Yep, don't write it again. So, did I take every p and divide it by every q? Luckily, this only has 6 numbers in it. This is the possible rational zeros. So I have a list of 6 possible rational zeros. Could everybody get that list if they asked you to list the possible rational zeros? Now, part B says, use synthetic division and find an actual zero. Use synthetic division and find an actual 0. So, before graphing calculators, we had to take every one of these numbers and do synthetic division with them. And we would know when we had an actual 0 because the remainder would equal what number? 0. Remember the factor theorem says remainder has to equal 0? Well, we would be lucky if we had this problem because there's only 6 numbers here. But the last one that I just took off the screen had 16 numbers. Do you imagine doing 16 synthetic divisions to see which one works? Wouldn't that be a royal headache? So we're not even going to do 6. Aren't you glad? We have graphing calculators. It's going to save us time and paper. Because I used to have to do synthetic division and do it again and do it again and do it again, and we would waste about 4 sheets of paper trying to find the one that worked because we just guessed until we found it. So now we can say, I'm going to take this list and I'm going to look at my calculator and we're going to decide which one is the actual 0. So turn on your calculator and go to y equal and type in your formula. I'm going to type it on mine and then I'll try to see if we can get mine to stay on the screen without being too dark. Let's see, on y equal, I would put in 2x to the third minus 5x to the second plus x plus 2. So type in your formula in y equals. Let me put this on here and see if it shows up okay. And then I would put zoom standard. Let me move it over a bit. Now, I know it's a little bit dark, but can you kind of see that this goes up and down and up? Does yours look like kind of like that picture? Okay, now, if I said, compare that picture to this list of numbers, which number from this list does it look like this one on the left could be? -1/2. Does that look like it's between 0 and -1? That's probably -1/2. Now, what does it look like the second one is? +1. That's what it looks like to me, too. And what does it look like the third one is? +2. Are all 3 of those numbers in this list? So, pick your favorite number out of those 3. It doesn't matter which one you pick. Pick whichever one you want. Does everybody like 1? Okay, we're going to pick 1 then. Now, just be aware. You might pick 1, your friend might pick 2, and your other friend might pick -1/2. Would all of them supposedly work? Yeah, so pick one of them. It says to use synthetic division to find an actual 0. Well, according to the calculator, we decided that 1 should be a 0. Didn't we look at the picture and look at the list and say it needs to be a 1? So I'm thinking my 0 is 1. That's what I'm thinking. Now, think about the remainder theorem from last class. Do you remember C? And the factor theorem says if the synthetic division gives you a remainder of 0, then C is a 0. So what are we thinking C is? This number, 1. So I'm going to say C is 1. So in my mind, I'm thinking C is 1. Now, when I take my f of x, what do I have to divide by according to the remainder theorem? Right, it's x minus c, right, x minus c. So what are we going to divide by? X minus 1. Do you remember f of x over x minus c from last class? So we have to remember that. And then I would say, is my f of x in descending order? And is it listed? Every term. Third power, second power, first power constant. So we have it descending in every term listed. And then I set up my synthetic division. So they say use synthetic division. So I have a 2, a -5, +1, and 2. And if this is x minus 1, what goes right up here? If that's x minus 1, what goes right here? 1. Why is it positive? What do you always do when you're doing synthetic division? Change that sign, right. And then right below we put plus 0 and we draw our line. Now, is that identical to what we did last class? That's the exact same thing. So now add and multiply. 2 plus 0 is 2. 2 multiplied by 1 is 2. Negative 5 plus 2 is negative 3. Negative 3 multiplied by 1 is negative 3. 1 plus negative 3 is negative 2. Negative 2 multiplied by 1 is negative 2. And what's the remainder? Now, if my remainder is not 0, then I know I messed up somewhere. Because if we're saying our first 0 is 1, then doesn't the remainder have to be 0, according to the factor theorem? So we just used synthetic division, and we found an actual 0. Is everybody good with part B? Right, that's what they said to do. Now, in part C, it says, find the remaining zeros. Now, I'm going to need another sheet. We're going to run out of space here. Find the remaining zeros. Now, before we find the remaining zeros, let's write down the ones we already know. Let's get this up just a bit. What 0 do I already know? Which one did I say in part B? 1. 1 is a 0. So I already said 0 is 1. So one of the zeros is 1. So I already had that in part B. And according to the factor theorem, if 1 is a 0, what is one of my factors? According to the factor theorem from last class, if 1 is a 0, what is one of my factors? X minus 1. Remember saying the denominator is a factor if the number is a 0? So x minus 1 is one of my factors, so I'd write that down. Okay, where do I find the other factor? When you do your factor theorem, where does the other factor come from? Starts with a Q. Remember that vocabulary word from last class? The quotient, right, the quotient. I'm looking at this synthetic division. What's the quotient? We had an x to the third to start with, so what goes right here? 2x squared, and then we have minus 3x, good, and then minus 2. Does everybody remember that's the quotient? So I need to write down my quotient here. 2x squared minus 3x minus 2. Okay, so part C says find the remaining zeros. And you can't find the remaining zeros until you write down those two factors from the factor theorem. Okay, is everybody okay with the factor theorem in order for us to do part C? All right, now I'm going to remove part B because we don't need it anymore. We're going to just find the remaining zeros. So if I said, find the remaining zeros from this, what would you do? We already know this one's going to give us the 1. How am I going to find these zeros? Factor it, right. So if I said, let's factor it, what are we all going to do? Well, that's 2x squared, so what do I have to put first? 2x and x, right. I know that's 2x and x. Now remember, when I do the outer and the inner, it has to add up to negative 3. But when I do the last, what do my last numbers have to be in order to get a negative 2? I have to have a 1 and a 2, right? Now, I don't know whether the 1 goes here or the 2 goes here, but it's got to be 1 and 2 or 2 and 1, right? One or the other. I think it's 1 and 2. Here's why. If you are trying to get negative 3 in the middle and you think FOIL, when you do the outer, what am I going to do with these two 2's? Multiply them. Wouldn't that give me a 4? If I have a 4x and a 1x, is there a way to get a 3x? So that's why I'm thinking the 1 goes with the 2 and the other 2 goes with the x. So when I do this, I have to figure out my signs. So which one's a plus and which one's a minus? Plus, which one? 2x plus 1, and then this is a x minus 2. Because when you do the outside, you get a negative 4x, and the inside is a 1x. If I have a negative 4 and a positive 1, am I going to get that negative 3 that's in the middle? Yeah, so that's what I would do to factor it. And we already found this one, this x minus 1, we already found, and it was x equals 1. Right, and that's the one we already had. But it says find the remaining ones. So 2x plus 1 equals 0. X minus 2 equals 0. Subtract 1. Divide by 2. X is negative 1/2. Here we add 2. X is positive 2. So when it says find the remaining zeros, don't put 1, negative 1/2, and 2. Why not? What's the word that tells me not to put all three of them? Remaining. In part B, are they going to ask us for one of them? If in part B you put 1, then what do you have to put in part C? Negative 1/2 and 2. Are those the remaining ones? Now, say your friend did this problem, and in part B they put 2. What's your friend going to have to put in part C? 1 and negative 1/2. So do you have to be careful when it says remaining? Right? Don't put the one you already had from the previous part. Now, on many of the homework problems, it will say find the remaining ones. And if it says remaining, don't put the one you already had in the previous part. But occasionally, it will just say find all zeros. Now, if it says all, do you have to include the one from the previous step? Right, so be careful. Watch for the wording. How did I know I was supposed to have 3 zeros? This was degree 3. Do I have 3 zeros? Yeah, I sure do. So these are my 3 zeros. 1, negative 1/2, and 2 are my 3 zeros. Any questions or comments on how to find the zeros when they don't give us a hint? So if we have no clue on what the zeros are, we have to do our P's and Q's. And once we get that list, can we look at our calculator and that list and know what to pick? Yeah, so it gives us a starting point. And then once we get started, it's just like last class. So that is what we're doing in today's lesson. Now, every semester, somebody says, well, why couldn't I just look at the calculator? Didn't we know all 3 answers from the calculator without doing any of this work? Yes, we did. But just remember, some of the problems are going to be like this one, and you'll be able to look at the calculator. But will all the problems be like that? No. And when it says find all the zeros, is it possible that some of the zeros could be messy numbers like square root of 2? And you can't use a calculator to figure out, oh, that's square root of 2, etc. So some of them are going to be messy. And others of them, will we end up with imaginary numbers? Do you remember I? Is it possible we could have imaginary numbers? So the calculator only helps us to a certain point. That's why we learn this process. So when we do the easy ones, I'm going to do the same process that I do with the hard ones. Just so you know, that's the way the thought process is. But when you're doing these problems, if you get a really nice one that you already know the answers for, could you just write in your answers and be done? Sure, the calculator can help us on several of them. But just practice on some of them so you'll get the hard ones and the easy ones. Now, after having us do problems like this, they're going to give us problems where they ask us to work backwards. So here we go again, working backwards. Excuse me. A lot of pollen in the air these days. I apologize for that. Sneezing into the microphone. Okay, here's a problem number 26, and it wants us to work backwards. It's in the same section. We're still in section 4. And on this problem, it says, find the nth degree polynomial function with real coefficients satisfying the given conditions if you're using a graphing utility, use it to graph the function and verify the real zeros and the given function value. And in number 26, they'd say n equals 3, and they have 4 and 2i are zeros. Does it say 3i? Number 26? I have a 2i in my book. Well, thank you for checking, though, because I make careless mistakes a lot. I apologize for that, too. Okay, those are zeros. Okay. 4 and 2i are zeros, and it says f of negative 1 equals negative 50. Okay, make sure I don't have any other careless mistakes. Somebody double check. Does that say exactly what the book says on that problem? Okay, so it says to find the nth degree polynomial function. Find nth degree polynomial function. That means I got to come up with the formula for f of x. So, thinking of what they're giving me, we have a small problem. First of all, this says n is 3. So when it says nth degree, then what's the degree of my polynomial? Degree 3. Now, if it's degree 3, how many zeros am I supposed to have? 3. Did they give me 3 zeros? Did they give me 3 zeros? No, they only gave me 2. The degree is 3, according to this. And then they said, these are zeros. There's only 2 numbers there. We have to figure out the third zero before we can come up with the formula. So when we're working backwards, sometimes we need extra information. Now, if you see zeros that are not rational, if you see zeros that are not rational, now, does everybody know rational numbers can be written as a fraction? Right? Can the number 4 be written as a fraction? 4 over 1? Right, so 4 is a rational number. So when you see the integers and the numbers that are fractions, those are okay. But if you see zeros that are not rational, for example, 2i, would everybody agree that's not even real? When your zeros are not real, they have to come in pairs. And here's why. Do you remember I is the square root of negative 1? Now, think about zeros. When we have zeros, don't we have to set something equal to 0 and solve it? If I had an x squared and it equals a negative 1, wouldn't I get an I? But if I have an x squared, when I do square roots, what do I have to put in front? Plus or minus. Remember that plus or minus symbol? So anytime I get an I, would I have been dealing with perfect squares? Yeah? And if I'm dealing with perfect squares, what's going to have to be in front of it? A plus or minus. And did they tell me that there were 2 of these? Nope, they only gave me 1. So if 2i is a 0, then that means negative 2i is a 0. Negative 2i. So when I look right here and I see 2i, I would also say and negative 2i, because plus or minus means one's a positive 2i and the other one's a negative 2i. Are you with me on plus or minus, meaning positive, negative? They come in conjugate pairs every time. So I see this, and I see this, and I think of this. So then I say, okay, these are my zeros, so x equals 4, and x equals 2i, and x equals negative 2i. Now I have all 3 of my zeros. Why did I say x and not y equals? Why do we always say x when we're looking at zeros? X-intercepts. Aren't zeros x-intercepts? And if they're x-intercepts, are they x values? Yeah, so we'll always have x equals. So I write down all three of my zeros. Now, think back to last class. How you work backwards. How am I going to take x equal 4 and find its factor? Right, minus 4 on both sides. If I minus 4 on both sides, I get x minus 4 equals 0. Remember doing that last class? Right, we're doing the same thing. Now, what if I have x equals 2i? What would I do to get that factor? What am I going to do to get that to equal 0? Subtract the 2i. So wouldn't that be x minus 2i equals 0? Okay, how about the third one? X plus 2i equals 0. So if I have my zeros, can I work backwards and get my factors? Now, what do we know about all factors? They're multiplied. So what am I going to put here? I think f of x equals what? What would I put here? X minus 4, and this would be x minus 2i, and this would be x plus 2i. That's what I think. Now, the reason I'm saying I think that's correct is because I don't know whether this graph has a stretch. Do you remember stretch? I have no clue whether this graph has a stretch or not. So, without the stretch, would these be my factors? Yeah, if there's no stretch, this would be it. But if there's a stretch, then I'm going to need some number to be multiplied by it right here. So now we have to figure out whether there's a number there or not. So what I would like for you to do is, first of all, multiply everything out so you get degree 3. Don't we need a degree 3 polynomial? Here's some advice. These two are conjugates. Are conjugates easier to multiply? Yeah, multiply the two conjugates first if you have conjugates. So the x minus 4 is still here. And when I multiply conjugates, what happens? I don't have to do the entire FOIL. What's the shortcut for conjugates? Anybody remember from intermediate algebra? When you have conjugates, what part do you multiply together? Right, first and last. Right, first and last. If you forgot that, could you do the entire FOIL? Yeah, and in the entire FOIL, would the middle cancel out? Yeah, so you're welcome to do the entire FOIL if you wanted to. But if you just do first and last, you have x times x is x squared. And what's negative 2i times positive 2i? Negative 4i squared. Right, so I just did first and last because they're conjugates. But what's I squared? Negative 1. I squared is negative 1. So what does that do to this negative 4? Right, we end up with an x squared plus 4. Did you notice I went away? Did everybody notice there's no I now? When you are doing your polynomials and you're working backwards, guess what will always end up going away? All the i's. They will totally go away because you'll end up with I squared, and if it's I squared, can we change it to negative 1? So, how do you multiply x minus 4 times x squared plus 4? Are those conjugates? Can I do first and last this time? Nope, first and last won't work. They're not conjugates. So what do I have to do on that part? FOIL method? Okay, so let's all multiply this out. I'm getting x cubed plus 4x minus 4x squared minus 16. But I wouldn't leave it in that order. What should be right after the x cubed? The x squared, right. So let's change the order. Now, I'm running out of space again, so I'm going to pull out another sheet. That's the only thing I don't like about doing it up here, is that we run out of rooms. So I've got my f of x that I think is f of x. And I have x cubed minus 4x squared plus 4x minus 16. And I want to know, is that correct? Is that the answer? So look back and let's see what we have not used. Okay, first of all, before I move that screen, does everybody understand how to do their FOIL and how to get this? Is everybody good up to here? Okay, then I'm going to cover up some of this stuff. We're going to go back to the given information. Way back at the top, if I can scroll this down. Way back at the top, we've used n. Is this degree 3? So that looks good. And we used our zeros to get all of this. Did we use this? Not yet. That's what tells me whether this is correct or whether there's a stretch. Now remember, if there's a stretch, what am I going to have to put right here? Some number, right? I'm going to have to put some number there if there's a stretch. So the only thing I have left to do is figure out the stretch. Now, according to the given information, it says f of -1 is supposed to equal -50. That's given information from the top. So, if I put -1 in the place of every one of these x's, and I get -50, well, I know that's the answer. Yeah, but if I don't get -50, well, I know I got to do something else. Right, so put it in and let's see what we get. So we're going to check it. It might work, it might not. I think f of x would give me this. I have -1 cubed minus 4 times -1 squared plus 4 times -1 minus 16. And if you do that arithmetic, let's see, that's -1 minus 4 is -5 minus 4 is -9 minus 16. I got -25. If you do it in a calculator, do you get -25 as well? Yeah. It's not -50, so my answer is not correct. But am I close? Now, here's what you have to do to figure out what number goes here. I got -25. I was supposed to get -50. What do you do to -25 to make it become a -50? Times it by what? Times it by 2. So guess what my stretch is? Stretch by 2. If I were to say, multiply everything here by 2, would that make this a -50? It sure would. So where did I get the 2 from? From the fact that this was not -50. I need to multiply by 2 to get the -50. So, go back up here, put a 2, and put a parenthesis. The 2 came from the fact that this needs to be doubled to get this. So then I go back to what I had, and I put a 2 here. Now, why did I put parentheses? Because when you're multiplying, what property do you have to use? Distributive property. So let's do our distributive property, and we're going to write the final answer. Working backwards is challenging. The final answer would be f of x, instead of it equaling what I thought it equaled, f of x actually equals 2x cubed minus 8x squared plus 8x minus 32. I believe that's correct. Did we just work backwards and figure out the polynomial function? Boy, are these challenging. Questions or comments on how to work backwards? Questions or comments? Okay, so they're going to give you some problems where they make you come up with the formula. They give you all the information, they make you come up with the formula. Anytime they give you this information right here, f of a number equals a number, that's when you have to figure out your stretch. All right, so that's information to help us figure out our stretch. Okay, in that problem, they said you can check it on your calculator if you want. When I read through it, did you notice it said you can check it on your calculator? Go to y equal and type in this formula. y equal, hit clear, type in 2x cubed minus 8x squared plus 8x minus 32 in the y equal. Let me slide this over so I can show this. Oops. And then let's do zoom standard. Now I can't see the picture too good, but when I had my zeros up there, didn't it say 4 and 2i and negative 2i? 4 is the only one that's real. So where does this graph cross the x-axis as far as real numbers are concerned? Does that look like 4? Did I just check to see if 4 is on here? Now, you can't check 2i and negative 2i because they're not real. And if they're not real, are they going to be on this graph? They won't be on the graph. But you can check the f of 1. I'm sorry, f of negative 1. Hit second table. Go to x equals negative 1 and see what y equals. Second table. Go to x equals negative 1. What does y equal? Does it say negative 50? So can we check that part? So you can't check the imaginary ones, but can you check the real ones? And can you check to see if your function is equaling the number they say it's supposed to equal? So we can check that part on these. All right, that was working backwards. Now, I don't know why in this lesson they have us going forward, and then they have us working backwards, and then all of a sudden they switch us back to going forward again. But here's another problem where they want us to go forward. And this one is really long. This is number 45. Number 45. And I'm going to make sure I don't make a careless mistake writing it down. Okay, x to the 4th minus 3x to the 3rd minus 20x squared minus 24x minus 8 equals 0. And it says solve the equation. Oh, I'm sorry, that's crooked. Solve the equation. Now, if I were given that problem on test 1, my first thought would be descending order and equal to 0, factor. Right, that would be my thought, just like on test 1. And then I would look at this problem and I'd say, oh no, I can't factor that. That's degree 4 and it has 5 terms. We don't know how to factor it. So then my next thought would be factor theorem, but did they give me a hint? No, we don't have a hint. All it says is solve. So if I don't have a hint, where am I going to get my hint from? My P's and Q's. Are you with me on the thought process? Now I need my P's and Q's. So write down all your P's. We're looking at negative 8. Negative 8. I'm thinking 1 times 8 and 2 times 4. So that's plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Did everybody end up with that list from the number negative 8? Okay, what's the leading coefficient? What's my Q? Right, there's a 1 in front of x to the 4th. Does everybody understand there's a 1 here? What are the factors of 1? Just 1. So we say plus or minus 1. Plus or minus 1. Now, we're lucky. What's going to happen when I take every one of those P's and I divide it by that only Q that we have? I'm just going to get that list of P's, right? So P divided by Q this time equals plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Since we're only dividing by 1. So there's my list of possible rational zeros. Every semester, somebody stops here. Am I supposed to have 8 answers? No. How many answers am I supposed to have when I'm solving this equation? 4 answers, not 8. So it can't be all 8 of these. So how am I going to know which one to pick? turn on my calculator and put in my formula. Okay, so turn on your calculator, go to y equal, hit clear, and type in x to the 4th minus 3x to the 3rd minus 20x squared minus 24x minus 8. Now let me make sure I don't have a careless mistake on mine. X to the 4th minus 3x to the 3rd minus 20x squared minus 24x minus 8. Okay. And then graph it in a standard window. Zoom, standard. Since all of those numbers in that list are between -8 and +8, a standard window should be good enough. Now I'm looking at this picture. If I were graphing it, it would not be a good window. Can you see that it comes down and goes up and then comes down, and then somewhere down here it turns around and goes back up? But I'm not seeing the bottom. However, we don't need to graph it. We just need to look at the zeros. Can we see the zeros without changing the window? Yeah, so I'm not going to change my window. But I need to look at that list of 8 numbers and find at least one of my zeros. What do you think one of them is? -2? Does everybody think -2 could be one of them? Okay, it could be. What's another one that we're possibly sure of? Maybe -1. Right? It's kind of hard to tell whether it's -1 or not, isn't it? Okay, and what another possible one? Well, actually, that's it. That's it, because that doesn't even look like 8, does it? In the 8 right here? Yeah, that's certainly not 8. So I'm thinking -2 or -1 would be the best bet. So let's try -2. We're going to try -2. -2's in my list, and it looks like it crosses at -2. So I would then, let me just leave this to the side and get it out of the glare. I would just say, I think my 0 is -2. So I'm going to do my f of x divided by what? X plus 2. Right, remember if that's a minus, this is x plus 2. And then I do my synthetic division. Now, is this descending order? And are all the terms listed? I think it is. So put your synthetic division. We have a 1. Remember, there's a 1 in front of x fourth. Then we have a -3, -20, -24. I'm going to have to move this. And a -8. And what number goes right here? -2. Good. And then I put plus 0 and draw my line. Okay, could everybody set up their synthetic division? All right, add and multiply. 1 plus 0 is 1. 1 multiplied by -2 is -2. -3 plus -2 is -5. -5 multiplied by -2 is +10. -20 plus 10 is -10. -10 multiplied by -2 is -20. I'm sorry, +20. I'm making a careless mistake. And then -24 plus 20 is -4. And then -4 times -2 is +8. And then what's -8 plus 8? 0. Thank goodness we got a remainder of 0. So are we 100% sure now that -2 is a 0? Yes, the factor theorem says if the remainder is 0, then yes, that C value is a 0. So I just did my factor theorem. But here's the problem. This was degree 4. What degree is this quotient going to be? Degree 3. Sometimes can we factor degree 3 by grouping? The problem is it's only sometimes. Sometimes will grouping not work? So when I start with degree 4 and this is degree 3, I choose to do synthetic division twice. because synthetic division is easier than factoring by grouping, especially since not all of them factor by grouping. So I'm going to do the factor theorem twice in the same problem. Now, we looked at the picture and we said -2, it looked like it was a 0, and then somebody else said they thought -1 was 1. Didn't we say we thought -1 was 1? So now we're going to say, I think another 0 is -1. I think there's another 0 at -1, based on the picture we looked at a few minutes ago. So here's what we do. Don't go back to the original problem. Now, I'm going to repeat that. Don't go back to the original problem. When you do synthetic division your second time, never go back to the original problem. Did you hear the word never? Never go back to the original problem. On test day, that's the most common mistake. Everybody wants to go way back up here. Don't go way back up here. Isn't this my quotient? And wasn't the quotient one of my factors? So I'm not going to take f of x and divide it by x plus 1. Why am I saying plus 1? Because it's minus a negative, right? I'm not going to take f of x and divide it by x plus 1. I'm going to take the quotient and divide it by x plus 1. Now, in the book, when they say quotient, they use q of x. So I'm not dividing the original problem by x plus 1. I'm dividing the quotient. And isn't this the quotient right here? This 1, -5, -10, -4. So you don't even need to write it again. If this is x plus 1, guess what goes right here? -1, and then I put plus and a 0, and I draw my line. Now, I'm going to do a second synthetic division using the first synthetic division. Look at what I just wrote. I took the numbers that I already have right here for my quotient, and to the left of it, I put my -1. Does everybody see where the -1 came from? Right there. And then I put plus 0. Now, add and multiply. Add and multiply. Do you get 1, and then multiply, and you get -1? And then when I add -5 and -1, I get -6. Multiply, -6 times -1 is positive 6. Add, and I get -4. Multiply, -4 times -1. 4. What's the remainder? 0. That's good news. That means we were correct when we said -2 and -1 were both zeros. Did I get another 0 for the remainder? Now, if you don't get 0 for the remainder, do you know you messed up somewhere? And you have to go back and figure out where you messed up. Right? So, when you have degree 4, you sometimes have to do synthetic division twice. What if we had degree 5? We would need to do synthetic division how many times to get down to degree 2? 3 times. What if I had degree 6? Do synthetic division 4 times. What if I had degree 7? Do synthetic division 5 times. So, the higher the degree, the longer this gets. We were degree 4, now this is degree 3, so what's this degree? 2, right? We need degree 2. If it's degree 2, we can always finish it. But if it's degree 3 or higher, we cannot always finish it. So every time you have a higher degree, do you have to do more and more synthetic division? So be aware of that, because you don't want to get caught up in the middle of it. And remember, never go back to the original should you just keep doing it based on the previous synthetic division that you just did. So just continue going straight down. Now, after I get to there, then I would say, now what? So, factor theorem is what we need now. So, now what? I'm thinking factor theorem. According to this, what is my first factor? X plus 2. So I put x plus 2. And according to this, what's my second factor? X plus 1. I'm sure of those two. And according to this quotient, now remember, we said we started at degree 4, and then this one was degree 3, and so this one is degree 2. So this would be 1x squared minus 6x minus 4. So my other factor is x squared minus 6x minus 4. And I specifically chose this problem on purpose because I know what some of us have trouble with. The thing that makes algebra so hard is that it's cumulative. Don't we have to remember everything every so often? Right? It makes it really hard. Why am I saying that? X squared minus 6x minus 4 was my third factor. Can you factor that? Is there anything we can multiply to get negative 4 that will add up to negative 6? What are the factors of 4? 1 and 4 and 2 and 2. Will either of those add up to 6? 1 and 4, 2 and 2. It's not going to factor. How are we going to solve it then? Because I need 4 answers, right? Wasn't this degree 4 in the beginning? I need 4 answers. I can get one answer here. Wouldn't that be the easy one? And I can get one answer here, and that's another easy one. How do I get the other 2 answers? The quadratic formula. That's exactly right. Does everybody remember the quadratic formula from test 1? Like I said, this is getting very cumulative. So these are easy. X plus 2 equals 0, so x would be negative 2. X plus 1 equals 0, so x would be negative 1. Those are the 2 we saw on the calculator. And then we have this. X squared minus 6x minus 4 equals 0, and it won't factor, so we need this formula. X equals opposite b plus or minus the square root, b squared minus 4ac divided by 2a. And we look at that and we say, okay, what's my a? What number is our a? 1, right? There's a 1 in front of x squared. What number is our b? Negative 6. And what number is our c? Negative 4. Is this review from test 1? Yep, so now we have to remember test 1 in order to be able to finish this problem. So I'm going to slide this up a bit because I'm running out of space here. And we're going to use our formula. Let's see. X equals the opposite of negative 6, which would be 6, plus or minus the square root of negative 6 squared. Isn't that 36? Minus 4 times 1 times negative 4. I think that's plus 16. And on the bottom, 2 times 1 is 2. Could everybody do the arithmetic? Are you still with me? Okay, what's 36 plus 16? 52? Somebody double check my arithmetic. I'm thinking 52. Yep, I got 52 on paper too. Is 52 perfect? No. Is there a perfect square that goes into 52? What number is a perfect square that goes into 52? Will 9 go into 52? Somebody said 9. No, 9 doesn't go into 52. What's the number that goes into 52? 4. Will 4 go into 52? How many times? 13. So when I see this, I need to think 6 plus or minus square root of 4 times 13 over 2. And square root of 4 equals what number? 2. So this is 6 plus or minus 2 square root of 13 all over 2. Am I finished? Not quite. Almost, but not quite. So now what do I do? 6, 2, and 2. What do I do to that fraction? 2 goes into 6 3 times, 2 goes into 2 1 time, and 2 goes into 2 1 time. So when we reduce, what are my 2 numbers? Right, 3 plus or minus square root of 13. So they asked me to solve the equation. What are my 4 answers? So I'm going to write the 4 answers on this line down here at the bottom because we've erased about half of what we had written. What was the first answer? Negative 2. What's the second answer? Negative 1. What's the third answer? 3 plus square root 13, because in the